you configure the port channels and everything. So I'll configure the port channel, on the ASA, and we'll see how those things work. I'll show you a couple of outputs, okay? And then we'll move into and start with next generation firewall, okay? So one of them would be, in case of clustering, we have the concept of master and slave, okay? So one is the master, and all the units in a cluster, they are basically slaves, okay? And also another difference between your typical high availability that we have seen here and clustering is high availability, whether you say active, whether you say active standby, it's limited to only 2 units, okay? So there cannot be more than 2 units in a failover, HA. In case of clustering, you can have up to 16 devices in a cluster, okay? And one of them will be the master, which will take care of the configure application, the state replication, everything, and exchanging the traffic and the data. And all of the other devices will be the slaves. Okay. So in here, this will be a port channel. So we are going to be implementing the switched mode or the spanned mode. All right. This is going to be a port channel. This is going to be a port channel. Okay. We have this configured in VLAN 10. This is here in VLAN 20. Okay, so this can be your Nexus switches and whatever, right? And this would be your uplinks. These would be your downlinks. And then in the middle somewhere, you'll have your cluster. There'll be port channels. Obviously, if you have more devices here, there'll be more devices. All of them will be in a port channel. Okay. And this guy will be the master, the CLM, and then CLS would be the slave. Okay. Let's first come into our ASAs. So fresh ASAs, again, they are those same ASAs which have that that hardware location. Okay. Cluster is enabled. Again, a licensed feature. Okay. Say M. First thing is to change the mode, basically interface mode. Okay, so when I say mode, in case of cluster, it's not an ASA mode, something like we configured for the multi-context, where we said the ASA mode is multi. Okay, this is just the interface mode. Okay, the mode of the interface. It can be routed, it can be switched. If it's routed, each individual interface will have an IP address. In case of span mode or the switch mode, your port channel will have an IP address. So individual interfaces don't get an IP address, but the port channel that you create, that is the one that will be configured with an IP address. Okay. So cluster, interface mode, and we have a couple of options, spanned or individual. Okay, so this is the routed one, this is the switched one. We're going to say spanned. Okay. It says, please complete interface and routing configuration before enabling cluster. Okay. And this needs to be configured on both the master, and all of the slaves. Okay. So all of them needs to be configured the same way. And in case of cluster, you don't have a failover link. You still have a link. This is basically called CCL, or cluster control link. Okay. In our case, this is Ethernet 3, come interface E3, and we're going to enable it. Okay. And we'll configure the cluster commands.
Cluster link is a layer 2 link or something different?
I'm sorry, it's layer 2.
Okay.
Right. The cluster command, we're going to say cluster group. Just name it anything. I'm going to say local unit is ASA CLM, right? And it's just a name. Okay. Can be anything. And we're not going to give it an IP address, just like we did the other one. And in this case, we have 172.16, same thing, right? But I just used the same IP address. Say cluster interface number IP 172.16.16.1 255.255.255.0. Okay. I now configure a priority. The lower the priority, the better. So your master will have the lowest priority, and then your slaves will have the highest priority. So whoever has the lowest priority within a cluster becomes the master. If the master fails, then the next device or another device who has the next lowest priority in the cluster gets promoted to become a master. Okay. So since this is a master, I'm giving it a very low value. And you can give the priority value from anything from 1 to 100. Okay. And it's used for master election. I'm going to say priority 5. Okay. You can also use a key. This is basically to encrypt your password and everything. Okay. So I'll say Cisco 123. Okay, it's used to authenticate the units. So it's basically can be used to prevent any rogue devices from joining the cluster. Okay, so all the units need to be configured with the same key, with the same password. You can also call it as a PSK or a pre-shared key. Okay, so everyone has it. When they join the cluster, they authenticate. Okay, to make sure that only reliable or known devices, or the ones who are successfully able to authenticate, they are the ones who are able to join and communicate within the cluster. Next is enable. Okay, that's fine. You can ignore that. So this is just saying that some of these commands, they are not compatible in clustering, which is completely okay. Okay, some of the inspections that are happening here, specifically for, so this is specifically for VoIP. SG23, that's your SG23 signaling, H225, and then that's RAS, that's basically used for gatekeeper. So if you ever work with VoIP or collaboration solutions from Cisco, they have a gatekeeper solution, or they used to have a gatekeeper solution. This used to be used for that. Skinny is Cisco's proprietary protocol for registration, for your media resources and all those things. And SIP is kind of like your industry standard thing for your VoIP communication and traffic. Okay, so these things are not supported in clustering. So that's why it's saying, hey, these commands are not compatible. It just gives you a notification, a warning.
But sir, Arun sir, default this all signaling protocols are allowed in ASA, right? Default.
Right.
Okay. But in cluster, we cannot, right?
It's just disabling the inspection. It does not. It is not saying that these protocols are not allowed.
Okay. Okay.
It's just the inspection that it's not configured. So basically, this is how you cannot configure the inspection.
Okay.
Okay. It does not mean that it is not
Because
supported.
my current domain is collaboration only.
Okay.
Yes.
Right. So I used to be in collaboration as well. Okay. So that's why I know a thing or two about collaboration. So yes. All right. So yes, your protocols still work. It's just that the inspection or these commands are not compatible. Okay. Now it basically says that so there was no other device currently available over that CCL. So this unit became the master currently. Okay. The transition from disable to master. So if I do show cluster info, we can see some information. Cluster is on. Interface mode is spanned. It is the master. Version, serial number, the CCL IP. Okay, the cluster control link IP, which is the link here, .1. We assigned it to this device. The MAC address and other members in the cluster, it's saying there is no other member in the cluster. Okay, so let's come over here and let's configure this guy as well. And it should be enabled for clustering as well. Okay, same thing. First thing is I'll change the cluster mode or the interface mode. Span E3, say no shut. And we're going to say right. Fun, you can copy all of this, but some of these things are different. For example, the name needs to be different. You can keep the group as it is. Cluster group, anything. I'm going to say local unit as ASA CLS. Say cluster interface E3 IP 172.16.16.2 255.255.0. Okay. Say priority, let's just say 10. It does not really matter now, okay, because I already have a master in my cluster. So, but I'll still give it a higher priority 10. Key needs to match what we configured on the master. And the last thing is to enable it. Okay. As soon as we did enable, it detected the cluster master. Okay. And it did some configuration replication. And it transitioned from disable to a slave. Come back to our master here to show cluster info. This remains the same. The other members in the cluster, this is now a slave. And you have all the different information about cluster. You have the name. When was the last time that it joined? When did it leave? Okay. So a lot of that information you can view from the cluster, right? So that's basically your initial cluster formation, right? Now, the next part now is to configure the port channel, okay? And we'll do the port channel first on the switches, okay? Once done on the switches, after that, we'll configure it on the master only. And all the configuration will be replicated to the slave. So let's come into our switch. First, we'll configure the out switch here, this guy here, okay? This interface here will be in VLAN 20. And this configuration really does not matter, okay? This will typically be whatever your network is going to be configured. It can be hundreds of VLANs here, okay? There can be Nexus switches, can be anything. I'm just, for the sake of completeness, I'm just adding the configurations. Okay. Let's come to this here. say out switch. Configure first VLAN 20. Okay. These two interfaces are going to be in port channel. So I cannot do interface range. I'll do interface E0/0, E0/2. Cannot do that. Let's configure it individually. Channel group. And we'll give it a number. Let's say 5. Mode active. And just do a no shut, sake of it.
Sir, only in ASA, LSCP, the channel is allowed, not PHGP and default mode.
Right. It's LACP.
Only ASA, right? Okay.
Right. Okay, so E00 and then E02. We're going to do the same configuration. We're going to say channel group 5 mode active and just do a no shut. Okay. This interface, we'll put this in that VLAN 20. Interface E0/1, switch port mode access, switch port access VLAN 20. That's the only configuration. Okay. You can do a show ether channel summary to check the information. It's using LACP, right? And currently they are in a suspended state. You see the S here, that's suspended. Why? Because the remote ends are not configured yet. We have only configured the switch side of things for port channel. The remote ports are not configured yet for port channel. That's why you see this in a suspended state. And it should show that here as well. LSCP currently not enabled on the remote port. Okay, so anytime you see S, it's bad. And anytime you see a P, it's good. Okay, so once we configure our ASA, you should see this status change to a P, which basically means bundled in port channel. All right, so that's the out switch. Let's do the same thing for the inside switch as well. Which is this guy at the bottom here. Okay, same interfaces. No, not same interfaces. E01 and E00. Let's first do VLAN 10. Say interface E00, I believe. Right. We're going to say channel group, let's say 6, mode active. Shut interface. You don't really need to unshut the port. They already unshut it switch, but I still have a habit of doing that. Interface E0/1, I believe. Yes, 1. Same commands. Okay. And one thing that I forgot was interface port channel 5, right? So the actual port channel, I want to put that into those VLAN as well. Okay.
Sir, why are you doing this port channel?
Sorry?
So why do we do this port channel actually?
Why do we do the port channel? Because this is basically a span mode. Okay. So if when I explained you yesterday as well, you have 2 modes. You can do the individual interfaces, or you can do the clustering. You can do it. You can have your ASA, primary, secondary, right? You can either have both of these connect to a router. They have an interface IP address here and here. You can either do that. Okay, that's one way to do it. If you're doing it in a spanned mode, which is basically not configuring IP addresses, then basically you configure these 2 interfaces in a port channel. That's your switch. That becomes your port channel. Same thing at the bottom here. So that's the way that you configure the clustering. That's why we need the port channels.
Thank you, sir.
All right. Okay. Configure, channel active. Base PO6. Okay. Right. So it's still in a suspended state. Now we'll come in and now we'll configure our firewalls. So that's basically the very basic configuration that goes into configuring your port channel on the switches. You basically configure the channel group and you assign those channel groups to the interface. Okay. Whatever the channel group is, that becomes your port channel interface. Okay. Now, when I say a cluster, all the units in a cluster, they behave as a single logical unit. Okay. Previously, when we're trying to do the high availability, the active standby or the active, I had to physically go in and enable the interfaces across. So here, whatever configuration I do master, it gets replicated in real time. Okay. So for example, if I come in here, if I do show interface, show interface, show run interface. Let's see which one. E0. Okay, it's in a shutdown state. Come on the master here. Interface E0. Okay, so first we'll configure the E0 interface. If I do no shut, it gets no shut on the standby as well, or on the slave as well. So I don't have to physically come in and do an unshut here. Okay. So when we are configuring both of them at the same time, in essence. Okay. So we'll configure this in port channel 5, and this will be in port channel 6. So now, channel group 5, mode active. Okay. Interface port channel 5. We're going to say port channel span cluster. And you basically configure a virtual MAC. It's recommended when you're trying to do port channel interfaces here, okay, or when you're trying to do the span cluster, okay. It's recommended to have a virtual MAC address. So that's what we're going to do. We're going to configure a MAC address. Can be anything. Obviously, it should be unique. So let's just configure AAA 111.12.12. Normal. Name if outside. This is going to be my outside network. Security level, it gets 0. And then we give it an IP address. And we can configure it anything. Okay, let's just give it 192.168 network. 192.168, let's say 1.1. Okay, and we are giving the IP address to the port channel. We are not giving the IP address to individual interfaces. Okay, the interfaces are going to be bundled in the port channel. Okay. No shut. Next, we're going to configure this guy here, ETH1. Interface E1, no shut. This is going to be in channel group 6, mode active. Interface port channel 6. I'm going to say port channel span cluster. Okay, and we'll give it a MAC address as well. Say AAA 111.1.2.3.4. Okay, anything virtual MAC. We're going to call this inside. This is going to be my inside part of the network. Same thing. If it would have been an individual firewall, one end would have been connected to the outside or the untrusted network. One would be connected to the inside or the internal network. P address, we can configure this to be, let's say 10.11.1. Shut. Okay. Now let's do, that's for the configuration. You can do show port channel summary. Okay. And that's my port channel 5. Show cluster info. Let's see. Cluster is there. Port summary. Bounce the interface once. E1. Shut, no shut. Support channel 5 here. One of the interfaces is showing as a P, which is basically bundled, and another interface is showing as suspended, which is E0. This one here. So let me just see what's happening. So it can take a little while for that LACP to negotiate and everything, and then for the interfaces to come up. Okay, that is possible. Still shows suspended. Okay, for some reason the clustering is transition from slave to master. So this became the master already. Okay, so this guy became the master for some reason. Let's see, show run, let's check config. E0, E1. It's fine. It's E3. It's my port channel, span cluster, side, start, cluster group. Okay, let's see. Just to still in that sync state. So let it sync. Okay. Start. Okay. Now these interfaces are bundled. We have a P. Okay, so P is always good. Come out to our, which is here. That's working. On the out switch, on the inside switch, we should have the same thing here. Okay, so port channels are up and functional. Your cluster is up and functional. Replication is done. Once you have done this, now you can configure your ASA just like you would a regular firewall. Okay, you can create your policies, your rules and everything. Okay. So the cluster configuration is a little bit complicated. Okay, the way that you have to do the configuration. Okay, but first enable your cluster, just complete the cluster configuration, and then enable your port channels. Okay. Okay, so that's what your clustering configuration should look like. And it can have, like I said, up to 16 devices or 16 ASAs or maximum 16 ASAs that there can be in this cluster. Okay.
So once the clustering configuration is done, the all other configurations should be done on the master.
Right.
What if I make in a slave? Would that be by mistake? If I make a change in slave, what happens? It remains just useless, or it's,
so what typically will happen is you put in the configuration on the slave. When you come back to the master, it will kind of remove that configuration. Okay, because it keeps checking with the master to see if its copy matches with that of the master. Okay, so if there's a mismatch in that copy, then whatever the master provides it will overwrite using that.
Okay.
Okay, and that's what's happening over the CCL link. That's where the heartbeats are being exchanged, and that is where your configuration replication is happening as well. Okay, so any configuration you do maybe on the slave directly, it will get overwritten with whatever is there on the master. Okay. Any question? Any other question related to clustering?
No, we will review in case of any questions.
Right. Okay. Let's get a quick 5-minute break. Okay. Maybe 10-minute break, and then we'll give it about half an hour to Firewall, to the and next generation firewall. Okay. We'll start that topic. I'll cover a couple of things initially. Okay. So what we have talked about up until now has been a layer 3, layer 4 firewall, right? Just basic access control list based upon what we call as 5 tuples. Your source address, destination address, source port, destination port, protocol. And if we add in the feature for MPF, then it can also do some deep packet inspection. Okay, see what's going on in that payload, do some basic URL filtering, and maybe some other stuff and QoS and everything, right? But an ASA is not really a replacement for a next generation firewall. Sure, it can do some things about next generation firewall, which is just URL filtering, right? But it's not a next generation firewall. Okay, so the current generation of firewalls we basically call as next generation. They are much more intelligent, they are much more sophisticated, and you could say they are much more complex as well in terms of the functionality, and they offer tons of different functionality. Okay. So your next generation firewall is still a layer 3, layer 4 stateful firewall. It is still that. Okay. It still has that state table, it still has that connection table entries and everything. It now has what we call as AVC, application visibility control. Okay, or you could call it, it is application aware or app aware. With the traditional layer 3, layer 4 firewall, you could tell that firewall that, hey, if the traffic is on port 80 or 443, take some action on it. Okay, now that port 80 and 443 could be running HTTP, or it could be running any other protocol, or maybe any other application. Your firewall was not aware about that. With next generation firewalls, we now have application awareness. Okay, instead of saying, hey, take some action on port 80, 443, I can say, hey, take some action on HTTPS traffic. Now, this HTTPS traffic can be operating or can be on port 443. Or it can be on 8443. From the perspective of the firewall, it is only looking for HTTPS. It does not matter what port it's traveling on. Okay, this is helpful in the current generation of networks where we have more sophisticated traffic. Okay, a lot of time attackers are trying to use these known ports to exfiltrate data. Okay, and if your firewall is not aware what the actual layer 7 payload is, okay, then I could be transmitting maybe DNS traffic over port 8443, 8443. Your firewall is not aware about it. Okay, so this gives you more application awareness. Okay, your firewall is able to identify the application. Okay. It is now also user aware. When I say user aware, my firewall knows where the traffic is coming from, whether it's coming from an HR department, whether it's coming from sales, whether it's coming from IT, who's the user, the username that's trying to send the traffic, all of that. Okay, so it is user aware, or it has user awareness. Okay. Another important aspect is the ability to have IDS and IPS. Intrusion prevention and intrusion detection. This is your signature-based malicious traffic. inspection. Okay. Another aspect of a next generation firewall is malware protection. And this could be against known threats, which will again be based upon signatures or signature based, or it can be zero-day attacks or zero-day threats, which are basically unknown signatures. And in case of zero-day, it needs to make use of some sort of an intelligent AI ML algorithm to determine the nature of the threat. Okay, and when I say malware, anytime I say malware, malware means protection against viruses, trojans, worms. Okay, any malicious code, any malicious software, any bad software, any bad piece of code, all of that is a malware.
The signature is unknown, then how it knows it's a threat based on some?
Through AI and ML.
Okay.
Through machine learning, it basically can analyze and see the behavior of that traffic in a sandbox environment and take some action. I'll talk about that in much more detail when we'll talk about malware protection.
Okay.
Okay. So it's based upon artificial intelligence and machine learning algorithms. Another aspect is antivirus, anti-spam. Okay. Can do email protection. Okay. Can also protect or help against DLP, data loss prevention. So all of these features combined and added into a single device, into a single product, basically makes it a next generation firewall. Okay. So in the earlier days, when we did not have the concept next generation firewalls, all of these products typically used to be individual products. Okay. So if you're trying to implement some sort of a protection in your environment, in your network, you would need to buy these separate products. You need to have a separate IPS IDS, a separate firewall, then a separate layer 7 firewall if you need to do layer 7 or application control or application awareness. Okay, then a separate data loss prevention product. Another thing that it helps with is SSL decryption. So nowadays, most of the traffic is HTTPS. Most of the traffic is web traffic, and it's HTTPS. We don't see a lot of HTTP outside of maybe a lab environment or maybe outside of a organization's limited environment. Okay, you won't see a lot of HTTP. So a lot of traffic nowadays is HTTPS. If you're trying to do some sort of a deep packet inspection, layer 7 inspection, you need to be able to first decrypt that data, decrypt that payload before you can do anything related to IPS IDS, any malware protection, any email protection, spam protection, and all of those things. So for that, you have the capability to do SSL decryption. Okay, and a lot of times you hear SSL decryption. SSL is no longer used. Okay, it's obsolete. You would typically should hear nowadays TLS. Okay, but SSL and TLS has been used forever now interchangeably. Okay, but anytime you hear SSL decryption, it basically means TLS. Okay, your transport layer security. And then another aspect, which I already talked about, is your deep packet inspection. Which you will quite often see as written as DPI. Okay, which would also mean layer 7 inspection. The actual payload or the layer 7 data. Okay. And it has your other regular stuff. It can do routing, it can do switching, it can do VPN. Okay, all of that. It can do NAT and everything. So that is kind of like your secondary thing. Okay, the main reason why you would buy a next generation firewall or implement a next generation firewall is to get you this protection. Okay, you would also sometimes hear this as UTM, Unified Threat Management. Okay, a lot of times you would see the products being interchangeably called as a next generation firewall and or a UTM. Okay, so it's a unified device. Okay, it's a single device which can protect you against a lot of these things or help you implement a lot of these things. A couple of other things that it can also help you is, one is URL filtering. Web content filtering. Okay, this can have things like your safe search or your YouTube edu. I'll talk about this when we come to that topic. We'll implement it in the lab and we'll see what it's all about. Okay, so all of this is what is your next generation firewall. Okay, anytime you hear next generation firewall, and you have several different vendors out there accomplishing your next generation firewall, right? Cisco is one which we are concentrating on. You have got Palo Alto, you have got your Checkpoint, right? You have your Fortinet. Sophos. Right, so these are some of the more common names that you're going to hear, and there are others as well. You have got SonicWall, you have Barracuda as well, which has a firewall, right? So all of them have their own version of next generation firewall, but all of them are providing you with these features. The naming might be different, the way the architecture is, that might be different. Okay, so they might do URL filtering a bit differently than what Cisco does, but they would implement URL filtering. Okay, the core concept remains the same when someone is trying to do or implement next generation firewall. Okay, from vendor to vendor, the concepts remain the same. The architecture obviously differs. Okay, that's basically your next generation firewall. Now, before I talk about from the Cisco's perspective and go into a bit more deep into the Cisco solution, I want to talk about a little bit about the history and overview of how Cisco evolved into the next generation firewall category. Okay, and if you have worked enough with Cisco, Cisco is very heavy and it's very aggressive when it comes to acquisitions. Okay, so over the years, a lot of their products, and I mean a lot of them, specifically most of their security products have come through acquisitions. Okay, so talking about a little bit about the history and dating back, so I'm going to start way back in the 1990s. Okay, the first Cisco product was Cisco Pix. It was a stateless firewall. PIX, Packet Internet Exchange. This was acquired again. This was again an acquisition. Okay, it came in 1994, and Cisco acquired it in 1995. Okay, it was basically a classic firewall.
But it's not a Cisco one. They acquired. I mean,
Right. So it came in 1994. They acquired it in 1995. Okay. So it was Cisco PIX, Packet Internet Exchange. Okay. Classic firewall, earlier days. It could do VPN and everything. Okay. It cannot, however, do remote access VPN. Okay. So that was one of the things that it cannot do, right? It could do site-to-site, L2TP, and all those things, but it cannot do remote access. Okay. There was another product, the VPN 3K concentrator. Okay. This was by an organization known as Altiga Networks. Okay. This was acquired by Cisco in the year, I believe it was 2000. And this was just a VPN headend. Okay. And it gave that missing piece that Cisco had with no remote access VPN. Okay. So Cisco now started selling both of these products, the PIX as regular firewall, it can do everything else. And then if anyone tried to do and wanted to have remote access VPN, then they could buy the concentrator and they could achieve that. So basically 2 different products were being sold. Okay. After about 5 years, I think it was in about 2004, 2005, Cisco came up with ASA, the adaptive security appliance. Okay. It added the benefits of both PIX and the VPN concentrator. Okay. And ASA is, I believe, one of Cisco's, it is one of their longest running products. Okay. Very successful product as well. And it has been so much successful that it's still sold. Okay. Yes, there are limited options. You don't have as much options as there are, but it's still sold. It still does not have any end of life yet. Okay. So it has been going on since 2005. Okay. So they kind of combined both of those products. They kind of gave the ASA, and then these products, both of these products, they went end of life, right? Now, this is from the perspective of firewall, right? This is how the ASA came into existence. Okay. Then around this same time, when the Cisco PIX was acquired, we had IPS at that time. There was in about 1995, 1998, there was a wheel group, or better known as the NetRanger project. Okay, this was 1998. It had Cisco's classic IPS. Okay, I don't think it was too much successful. It was sold quite a bit. It was tested on the CCI labs as well. Okay. This went end of life in 2014. Classic IPS. During the same time, NetRanger, another IPS, an open source IPS, came into existence. Which went by the name of Snot. Okay, same year, 1998, when the NetRanger project was there. This was an open source. This was created by a guy named as Martin Roche. He wrote the snot typically for his, so it was kind of like his own personal project. Okay. And since it was open source, it was available for people to test it. And it kind of become very successful. It kind of become very popular since, again, it was open source. Okay. It was successful as an open source project. So what Martin did was he started selling it commercially in 2001. So he founded SourceFire. And he started selling Snot as a commercial product. Okay. It was still available open source, but chassis and everything, he started, he built up a company for that. Okay. This was acquired by Cisco in 2013. Okay, so Cisco acquired. Okay, and since it got this IPS, which was very popular, that's when they kind of next year they kind of removed the classic IPS from their portfolio. Okay, so Cisco acquired it in 2013, 2014. The next year, they came up with Firepower module. Okay, came up with the Firepower module. Now this Firepower module, they already had ASA, which was providing the layer 3, layer 4. It did not have the signature-based inspection, the IDS, IPS capability. They got that from Snot. Okay, so what they did was here, they started selling ASA chassis with this module. And this was used to be called as SFR modules. So ASA modular chassis, you plug it, you used to plug this module into this, into the ASA chassis. And from the ASA, you used to use that MPF, those policy map, class map, to send that traffic to the module, whatever traffic needs to be inspected, and then back into the ASA, and then that's how it used to be. It was kind of not received with a lot of enthusiasm in the industry because they were trying to indicate two different sources of code together. So there were a lot of issues with it. Okay, there were lots of issues. So they stopped selling it after a while. In 2015, they came up with a much better solution, which was FTD. Firepower threat defense. Okay. This was their next generation firewall solution. It did not have ASA and module running. It was a single unified image or a single unified operating system. With this, they were running ASA, what we saw with ASA, okay? And it used to run the IPS separately, separate operating system and everything. When they came up with Firepower Threat Defense, it was basically a single unified operating system. You cannot tell the difference between the ASA, or basically you cannot tell the difference which part of the code was your IPS, which was regular firewall. So it was a single image. Okay, so that's what the FTD was, which came into existence at 2015. Okay. And in 2015 itself, they came up with the Firepower 9300 chassis. This is still their biggest chassis. This is meant for service provider and very large data centers and organizations. Okay, and it's a modular chassis as well. Okay. In 2016, they came up with 4100 series, which was meant for large organizations, maybe some small service providers, maybe medium organizations. Okay. And then next year, they came up with 2100 series chassis, which was 2017. This was meant for small businesses, small organizations that still wanted to take advantage of the next generation firewall. Okay, these were their hardware platforms. Okay, and there are a couple of more that I'll talk about in a bit. Another acquisition that I want to talk about is there was a malware protection product or a company that went by the name of Immunet. Immunet, okay, 2011. They had a product called as AMP, Advanced Malware Protection. It's acquired by Cisco in 2012. Okay. Why did I mention this? Because this is what, when I mentioned the malware protection, this is what Cisco uses, or you'll see nowadays. Okay, advanced malware protection. There are two variants for this. One is for network. Okay, for network transfers, you use it on next generation firewall, you use it on their other products as well. Okay, web security appliance and all those things. Another variant is AMP for endpoint, which is basically an endpoint protection. You can also call it as an EDR solution, endpoint detection and response. Okay, so in this basically course, we'll be looking at both of them. Okay. Any questions?
So this, sir, so this AMP is a hardware or a software application?
It can be both. So this is a client-based.
Okay.
Since it's for endpoint, it gets installed on your endpoints, your machines, your mobile phones, your iPads, your tablets, your servers. Okay. And then it can connect to the cloud, or it can connect to an on-premise virtual machine or a hardware.
Okay. Okay.
Okay. And this basically, this gets, or this comes as a service or a module built into FTD.
Okay.
Okay. And you enable it with the help of licensing.
Okay.
Okay.
Understood, sir.
Just a second, just a moment. Okay. Okay, sorry about that. Okay, so 2017, these platforms here, and over the years, they have gone into a lot more of these products. Okay, so in 2017, they also extended. In 2016, they also created the firewalls to be available on KVM, kernel virtual machine, basically Linux based. Okay, in 2017 they added its support for Azure. Okay, 2019 they came up with the 1000 series. Okay, 1000 series. And in 2020, they added support for GCP and OCI. the Oracle Cloud Infrastructure. Okay. AWS was added back in 2015 itself. Okay, so when the 9300 was released, the initial things that it got, it was added for AWS back then. So AWS has been, or it has been with AWS support for a very long time. Okay, so 2021 was GCP and OCI. 2021, they extended the support for Cisco Hyperflex. You could run it on OpenStack. You can also run it on Nutanix Private Cloud or your enterprise cloud. Okay. Quite recently now in 2020, they have released a new chassis, the 3000 series. Okay. So that's their complete range of products that that they kind of have to offer currently. Okay, and obviously there is no ASA-N module that is being supported. The current line that ASA has, so with ASA you can only purchase their 5500X series firewalls or their virtual ASAs, what we have been seeing in our lab, the ASABs. Okay, and you don't really put in any module here. So this, you can either run ASA on this, or you would run this unified image, FTD, either of those. And then if you have virtual, then obviously you can only run the ASA code on it, nothing else. Okay.
So what the 5500 ASA or FTD or ASA plus SFR?
This is an ASA chassis, ASA 5500X. Okay, so on this, you can either run the ASA code or you can remove the ASA code and you can run the FTD code on it. So if you have an existing ASA 5500X, you don't need to purchase a firepower chassis. You can remove the ASA code and run the FTD code on it, and it can function as your next generation firewall. Okay.
So like Arun sir, we have existing 5520 kind of ASA, and with the help of this module, we can make it a next generation firewall, right? That's what
So
you're saying?
there are no modules now. So this module is no longer being sold. It's EOL, end of life, end of sale.
Okay, okay.
Okay. So now if you have a firewall and it supports next generation firewall, so you can remove the ASA code, which basically means you would flash the ASA. And reinstall FTD on it. So basically, without changing the chassis, you can get the benefits of the next generation firewall. If you don't have an ASA chassis, then you'll have to purchase one of these firepower chassis.
Okay.
Okay.
So obviously in the old device, I will have ASA chassis, right? So I can remove and install it.
Right. So if we come on to Cisco's website, come into products and services, security, secure firewall. So I'll talk about the naming now. So you're not going to see firepower mentioned anywhere now. Okay. And I'll discuss this next. So let me just quickly show it to you, or let me just talk that about first so that it does not confuse you. So the way that the product evolution has happened, okay, and it's very important to understand the naming as well, because Cisco recently went through a naming change, a nomenclature change. So if I talk about the product evolution and life cycle. So in the earlier days, okay, it used to be called as firepower. This was pre-acquisition, before acquisition. once Cisco acquired it, they changed the name to Firepower. The difference is this uppercase. Anytime you see the power written as uppercase, it's basically is pre-acquisition. You could also see call these as legacy devices. After acquisition, when Cisco went on to produce all of these products themselves under their name, they basically moved everything to be that lowercase kind of a thing. Okay, and that's how you can tell the difference whether the product is a legacy product or a pre-acquisition or it's post-acquisition. Okay, and previously it used to be called as, like I said, FTD, which used to be meant as Firepower Threat Defense. Okay, they have now went through a change in the naming. Okay, this was with version 6. Okay, now they call their product as Cisco Secure Firewall. This is starting version 7. Okay, and this is what we'll concentrate in our training as well, on the 7 version. There have been some changes, a good number of changes, some very important ones. Okay, so that's why we'll be concentrating on the more recent release, okay, which is 7. So it can be either 7.0 that we look at or 7.2. Okay, Cisco Secure Firewall. This is the name that you're going to see nowadays. Okay, now if you come back in here, that's what you'll see, Cisco Secure Firewall. You have your 1000 series, 2100 series, 3100 series, and it basically mentions this is for small businesses and branch offices, it's for large branch offices, medium. And when you move into the 4100 series or the 9300 series, they are basically for large environments, data center environments, service provider environments. Okay, 9300 series is specifically meant for service providers. Okay, you then have the ability to run it on private clouds, things like your Hyperconverged or Cisco HyperFlex, things like your Nutanix Enterprise Cloud, which is a private cloud. Okay, maybe even your ESXi and those sort of things, KVM. I kind of consider those to be private clouds as well. Okay, so you could run all of those on that. Public cloud, there as well, AWS, Azure, GCP, OCI. Okay, and I think Alibaba and all of those are there in there as well. Okay, you then have the ability to have the ISA series as well. This is for industrial solutions. Okay, when I say industrial, I mean things like your factories and everything. Okay, so secure firewalls can be used there as well. Okay, they are much more robust because in industries and everything, where you have factories and everything, you have got high temperatures, maybe low temperatures environments. So these are built for that. Okay, these chassis, you would typically place them in highly ventilated, cool environments. Okay, otherwise they'll go bad. These are specifically meant, they have a rugged design. They are specifically meant for industries and operational environments. Okay, so if you're going to even see these chassis here, okay, this is what they're going to look like. Okay, so they are very robust made, very ruggedly made. Okay, and if you look at these chassis here, let's say maybe the 2100 series, for example, right? This is what they look like. Okay, and obviously these are your 1 rack units. Okay, these are 1 rack units. From here, you start getting into the more higher series. They're also your modular chassis. Okay, this is also 1 rack unit. Okay, this is basically your 2 to 4 rack units. Okay, so these are your modular chassis, and I'll talk about much more detail on this. What are the modules and everything? Okay, because typically in productions and everything, you would have or it is a possibility that you might come across 9300 chassis is a lot. Okay. But this is the highest that they have to offer. Okay. And depending upon what module you choose, and I'll talk about what these are. Okay. This will govern your resources. Okay. So the highest that you can go is 56 CPUs, which gives you about 190 gigabit per second of throughput. Okay. So 1.1 million connections per second. And they do it with AVC. Okay. They can do application visibility and still do 1.1 million connections per second. All right. So these are, again, that is some sort of a traffic that you would typically expect in service provider, your managed service provider environments. Okay. So that's the current naming convention that goes to it. I'll just cover a small topic before we end the day for today. Okay. Whenever we are talking about from the firewall's perspective, we also talk about how do you manage the firewalls. Okay. When we're talking about the secure firewall, is your next generation firewall. This is what actually sees the traffic. What about if we have hundreds of these firewalls? Okay. Or maybe 50, or maybe even 10, right? You either would go into individual firewalls and configure them, or you would have some sort of a centralized management solution through which you can manage all of the devices. Okay. So when we're talking about management, there are three options. One is on-box or local management. This is achieved through FDM. Firepower Device Manager. This is the older name. Or the newer name being Firewall Device Manager. Again, it's a web-based management. All of your firewalls, they ship with this software embedded, so you don't have to install anything else. Okay, it is on the box or local management. So through one FDM, you can only manage one firewall, which is that local firewall on which that FDM has been shipped with. Okay, so if you have maybe a single firewall, maybe two firewalls, then you can maybe use FDM. There are some limitations in features. Okay, not everything is supported when you configure it through on-box or local.
So if it is a single firewall, we can make the changes on the firewall itself.
You cannot do it through the CLI.
Oh, okay.
So now when we're talking about next generation firewall, nothing is configured through the CLI. Okay, so ASA, we configured everything for the CLI. The next generation firewall, nothing can be configured from the CLI, except for the initial configuration. Okay, everything needs to be configured from some sort of a web interface. Okay, if you're managing a couple of firewalls, you don't want to invest the money in FMC, though there are several reasons why you want to invest the money into a centralized management. Okay, that's the option that you have for FDM. So this is version 6. This is version 7. The naming change. Okay.
Can I log into the FTD through CLI?
You can log into the FTD through CLI.
But you are saying we cannot make any changes.
Cannot make changes. You cannot configure policies, rules, etc. from the CLI.
Okay. Okay.
The next option is out of box or centralized management. This is achieved through FMC. Firepower Management Center is what it used to be called. Okay. Now it is basically called Secure Firewall Management Center. And this is available as hardware, chassis, and it can also be virtualized. This is a centralized management. Okay, so you can manage 50, 100, 200 firewalls through a single point of management. Okay, the last option is
from which versions of this Firewall Management Center? Firewall Device Manager, you have mentioned these.
Yeah, so again, it's the same thing. This is version 6 and this is from version 7. So anytime I'm talking about a naming change, the naming change was introduced from 7.x, starting 7 version.
Okay.
The last option that you have is again a centralized management, but it's cloud-based. CDO. Cloud Defense Orchestrator. Okay. The difference between FMC and CDO is the FMC is the device, the hardware is all present on your premises. So you are responsible for the management of the chassis as well as the software. With CDO, everything is being managed by Cisco. The only thing that you manage is the login and everything, and then whatever firewalls you have registered or you are managing through the platform. Okay, so it's a cloud-based centralized management solution. Okay.
Is it SaaS kind of?
Correct. Software as a service. Okay, so in the training, we'll be mostly concentrating on this FMC. Okay, I'll still cover FDM. We'll bring in kind of like a branch or remote site where we'll only have FDM, and I'll show you what it looks like. And then when I show you the FMC, you'll kind of appreciate why you would want to have FMC rather than just being on FDM. Okay. So those are your different management solutions. When you manage a firewall, the firewall, next generation firewall, basically gets called as a managed device. Or you would see me reference to this a lot as sensors. So anytime you see the name as sensor or managed device, it means the actual firewall or the next generation firewall. Anytime you
actual
sorry?
Is it the sensors or managed devices? Is it
right
to FTP or
FTD? Yes.
okay.
Okay. And anytime you hear manager, that could be either this, this, or this. Okay. So typical solutions nowadays, yes. Whenever you're talking about next generation firewall, you typically have a manager, and then that manager manages different firewalls. Okay. If you take a look at other vendors as well, maybe Palo Alto has Panorama, okay, which is used to do the centralized management. If you talk about Fortinet has the FortiManager, which achieves the same thing. So irrespective of fact which vendor you go to, a lot of these core concepts will remain the same. The naming will be different, obviously. How the product looks like, how does it function, will be different, obviously. But at a very high level, if you learn about the Cisco next generation firewall solution, then moving into and learning any other vendor, any other product is relatively very easy. Okay, because you already understand the core concepts. Okay, so once you understand the Cisco side of things, if you move into Palo Alto and they say, hey, we need to centralizedly manage our firewalls, so you instantly know, or you instantly would understand that there needs to be a centralized solution. Palo Alto has Panorama, which kind of is doing the same thing which Cisco is doing with their FMC. Okay, and if we look at the solutions for the FMC, services, let's come into security. See all secure products. See firewall, workload, industry, firewall. That's my firewalls. Does not give me the management option here. Stick with resources. It's the management. It's Forrester. Let's see.
Sir, I have one question. So
Yes, go ahead.
in my setup, we have FMC and FTDs, and we also have the old ASA firewalls, which they access through ASDM. So
Okay.
I'm just confusing about the one they are accessing through ASDM. Is it ASA plus SFC, or is it just ASA, or is
It's
it
just
they
the
have
ASA.
included-
So just like your FTD has this on-box management, ASDM is the on-box management for ASA.
There is no FTD code installed, just ASA. That is just.
You can't really tell by that, but I can tell you if it's being managed by ASDM, yes, you cannot manage the FTD code through ASDM.
Yeah, that is for sure. They're accessing through
Right.
ASDM.
So if you're accessing it through ASDM, it's just an ASA firewall.
Okay, thank you, sir.
Okay. Okay, secure firewall management solution here. So these are the different, so basically 3 options for hardware. Okay, and the maximum that you can manage is 750 firewalls through a single chassis. Okay, that's a lot of firewalls. Okay, and you can see how much events and everything it can store. Okay, and when I say events, it basically means logs. Okay, this is the smallest one. It can manage 50 firewalls. Okay, and you can have high availability as well. Okay, so you can have 2 firewalls in a high availability active standby. All right, and then you have your FMC virtual, which can still manage 300 firewalls itself. So if you already have maybe an ESXi environment, okay, you can use the virtual. And you can use the FMC virtual to manage both virtual firewalls as well as chassis-based firewalls. Okay, so it's not like if you have virtual FMC, you can only manage the virtual FTDs. Okay, you can have a mixed match of that. Okay, so in our lab, obviously, we'll be looking at the FMC virtual solution. All right, so this is what the your FMC is now has. So the naming change is there. A couple of times Cisco will mention it in a couple of places that formerly it was called as Firepower Management Center. Now we call it as a Secure Firewall Management Center. Okay, because the FTDs are now called as Secure Firewall. So Secure Firewall is the firewall, and then the management center for them is Secure Firewall Management Center. Okay. Any questions? Right, okay, so we extended quite a bit today, okay? But I just wanted to talk about some of brief things. So next weekend, we're gonna dive more deep into it. By the time I'll get some time to set up the lab environment as well, okay? Any questions, guys?
Thank you, sir.
Thank you, guys. Take care. Bye-bye.
Bye.